Problem 4, we are back to using our graphing calculator. So if you don't have that handy, you can pause the video and grab that. We're going to graph the appropriate reciprocal trig function to find each value, round to 4 decimal places. So we're going to graph the secant of 80 degrees, and then we're also going to graph the cosecant of 30 degrees. I'm going to head to my calculator. You have your paper in front of you still, but I'm going to head to the calculator to show how to graph these. So when we're graphing, we're going to head into our y equals. And this first problem, we're going to put in secant of 80 degrees. So one thing you're going to want to go back and check if you haven't been watching the previous videos, you're going to want to go into mode. Since it's giving us an angle measure in degrees, we're going to want to change our calculator to degree mode. So we are in degree mode, we're good. We're going to head to our y equals. Now secant, you do not have a secant button, you have to use the definition of secant. So secant is 1 over cosine. A couple ways you can do that. If you have a calculator that does fractions, you can make a fraction. 1 over the cosine of x. Or you can just hit 1 divide cosine of x. So either one will make a secant. So we're going to graph 1 over the cosine of theta, and then we're going to go find where 80 degrees for theta is, and we're going to see what is the output of that 80 degrees. Let's head to our window next. So our window, you probably have it set up similar to this. Since we're dealing with degrees, think about a full circle. How many degrees are in a full circle? If you start at 0, after a full circle, you're going to be at 360 degrees. So now that our theta is in degrees, we want to change that x value to how a circle relates to degrees, 0 over 360. If you wanted to do 2 laps, or 2 pi, I guess is how we used to do it, 2 pi would be 720 degrees. I'm wrong on that. 2 pi would still be 360. That's one lap around the circle. But if you needed to go beyond 360, you can find other measurements beyond 360. Anyway, we'll head to our scale. We're going to change that to 90, just counting by 1/4. Now we get to our y min, y max. And we used to use the amplitude to help us with that. But now that these go up to infinity, we just need to get a picture of what these are looking like. So -10 to 10, I'm going to leave that as is and just kind of see what my picture looks like, and then see if I can find where that 80 degrees is. So if you have your calculator and you're still working on this window, you can pause the video right now to copy this window down and making sure your calculator is in degree mode. Now you hit graph. You should see your secant graph. So right through here is kind of our cosine. It's starting at 1, it's going down to -1, and then finishing up at 1 again. So there's your cosine kind of heading through there, and then we got our asymptotes wherever those zeros are. How can we find 80 degrees? Well, here's one way that you can do it, and the only way that I'm going to show you is you can hit second, calculate. You can calculate a value. Type in what value you want to find for theta. We want to find 80 degrees, so I'll type in 80 and then hit enter. And there would be your value for 80 degrees. I'm going to zoom in on that. You can take a look. Rounding to the nearest 4 decimal places, so 75877. That 7 rounds that up to an 8, so this would be 5.7588 would be our result. I'll show you that method one more time, and then I will remind you about the other method as well. But if you are using this method, you're going to hit second, calculate a value, and then you just type in which value you want to find. We're going to find 80 degrees, hit enter, and then there's our value. The other way is you can do a table set. So hit second, table set. You can change it to ask, and then you go to your table. When you're in your table, we'll clear out. I can't clear those out right now, but you can add it to whatever maybe you have in your table already when you changed it to ask, 80, and then it'll tell you your result. So that method again, second table set, you're going to want to change independent from auto to ask. Second window is how I got there. And then once you're in your table, you can tell it whatever you want to find. So let's head back then and look at problem number 4B. Problem 4B, I'm going to head back to my y equals. We'll clear this one out. We're now doing cosecant of 30 degrees. Well, we're going to graph cosecant, and there is no cosecant button. You're going to hit 1 divided by sine of x. If you have the fraction button, alpha y equals, go ahead. You can go 1 over sine of x. This will also work if you don't have the fraction button. Go to our window. We're going to go all the way to 360 degrees again, one lap around the circle. And negative 10 to 10. We'll keep that same window. We'll see how this one looks. Let's hit graph. So there's our cosecant, excuse me. So our sine graph starts at 0, goes up to 1, back through 0, goes down to negative 1. So there's your asymptote right here, asymptote right here, and then asymptote right where it starts. We'll do that first method we talked about last time. Second calc, find a value, and you're going to type in 30 degrees. And you're going to get a very simple number here, 2. Where is that 2 coming from? If you go back to your unit circle, 30 degrees is right here. What's the sine at 30 degrees? 1/2. Well, cosecant is the reciprocal of that number. So what is the reciprocal of 1/2? 2. Yes, 2 would be the reciprocal of that position. So filling in our answers, you can hit, this one was 5.7588. And reciprocal of 1/2, cosecant, was 2. So 2 methods using your calculator. If you need help reviewing those, just rewind the video. You can use your second calculate value, or you can change your table to an ask setting and then type in whatever value you want to find. So hopefully that helps, and we'll continue using the calculator for the next couple of problems as well.